Hello, chemistry students. Tomorrow will be the chemistry test over chapter 12, which is the states of matter. I wanted to go ahead and remind you that the test will consist of 7 questions. There will be 3 multiple choice questions, a question that concerns Dalton's law of partial pressures, 3 questions that deal with intermolecular forces, and a question that consists of multiple parts dealing with a phase diagram. And so what I'd like to do right now is to go over the study guide that I gave you a couple weeks ago. And so we're going to go ahead and start with question number 1. And so question number 1 asks to describe what is the kinetic molecular theory. And so this describes the behavior of gases in terms of particles in motion. And so that is what the kinetic molecular theory is. Question number 2, what are the 3 characteristics that describe the behavior of gas and define them? We have particle size, particle motion, and particle energy. Beginning with particle size, we know that gases are small particles that are separated by large empty space. Second, particle motion. Gas particles are in a constant random motion, and when it deals with particle energy, we can use the equation Ke equals 1/2 mv squared. Ke stands for kinetic energy, m is the mass, v is the velocity, and I want to remind you that there will be no problem like this on the test. Also, when we talk about temperature, what temperature actually is, it's the measure of the average kinetic energy of particles in a sample. Question 3, what is diffusion and what is effusion? Diffusion is the movement of one material through another, whereas effusion is how a gas escapes through a tiny opening. All right. We're going to also now look at Graham's law of effusion. And so we have 2 gases, which we are going to call A and B. We can describe the rate of effusion of gas A through gas B by taking the rates and dividing them into each other. This is going to equal the square root of the molar mass of B over the molar mass of A. And I do want to remind you that there will be no problem where you have to calculate this on the test. Now just be familiar with the concept, but there will be no calculation of this type. Number 5, what is pressure? Pressure is defined as force divided by area. And so there are several different ways that we measure pressure. One is using the kilopascal, which is kPa. We can also measure pressure using millimeters of mercury, which is this. We can also use the torr, T-O-R-R, which is short for Torricelli, who was the scientist who first invented the barometer. We also have pounds per square inch, PSI, so think about your car's tire pressure. And then the common expression for pressure is in the atmosphere, which we're going to abbreviate as ATM. All right, number 6, I put a star next to this because you will have a problem that will have you calculate something related to pressures, related to Dalton's partial pressures. And so the Dalton's law of partial pressure states that the total pressure in a system of gases, we just simply add up the partial pressures, and so we have partial pressure 1 plus partial pressure 2 plus so on until we end with the final partial pressure, so depending upon how many gases we have. And so there will be a problem like this on the test tomorrow. Question number 7. What are dispersion forces, and give an example? Dispersion forces are weak forces that result from temporary shifts in electron density in electron clouds. And so a couple good examples of this would be, for example, the noble gases, so things such as helium and neon, etc. But we also have to consider non-polar molecules, so things such as diatomic hydrogen, diatomic fluorine. These only consist of dispersion forces which hold the molecules together. And so that is the first of our 3 types of intermolecular forces. A second type of intermolecular force is dipole-dipole, and so these are attractions between oppositely charged regions of polar molecules. And so the example that I give you is hydrogen fluoride, also called hydrofluoric acid. Notice that we have, hydroiodic acid. Notice we have hydrogen and iodine. Iodine is highly electronegative, and so it's going to want to pull the electrons toward itself and away from hydrogen. And so if we have two molecules, we'll see that this region between the iodine of this one molecule and the hydrogen of this other molecule, this is the dipole-dipole forces. And so again, these are the attractions between oppositely charged regions of polar molecules. The iodine would be negatively charged, the hydrogen would be positively charged, and as you remember, opposite charges attract. All right, we can then move on then to question number 9. Number 9 asks for hydrogen bonds, and give an example. Hydrogen bonds are a special type of dipole-dipole interaction that occurs between hydrogen and oxygen, hydrogen and nitrogen, and hydrogen and fluorine. And so a very good example of this would be water. So notice water, of course, is hydrogen, but it also has the element oxygen. And so hydrogen bonds will only occur between hydrogen and oxygen, hydrogen and nitrogen, or hydrogen and fluorine. And so those are the 3 types of intermolecular forces. All right. Fluidity is the ability for something to flow, so liquids and gases have this ability. Viscosity is a measure of resistance to flow, and so that is the opposite of fluidity. All right. Surface tension is the energy required to increase the surface area of a liquid, and capillary action is a combination of both cohesion forces, which occur between the same molecules, and adhesion forces, which occur between different molecules, that creates that meniscus in liquids. And so that is where that comes from. All right. Number 12, how does density of solids compare to liquids and gases? And so in general, the density of solids is greater than liquids and gases. A very common exception to this, of course, is ice, where ice is solid, but it's going to be less dense than water, which is why ice floats on the surface of water. And so we can also explain this because the particles in a solid are typically more tightly packed. And so that's the answer for number 12. All right, finishing off, we're going to then look at the phase changes that require energy and define them. So we have 3. And so our first phase change that requires energy is melting. And so when we go from a solid to a liquid, we also have vaporization, which is when we take a liquid, heat it up to make it into a gas. And then we can also have the process known as sublimation, where we go directly from a solid to a gas without going through the liquid. All right. Then we also have 3 different phase changes that will release energy. We first of all have freezing, and so freezing is the opposite of melting, where we take a liquid and turn it into a solid. Condensation is the opposite of vaporization, so we're taking a gas and we're combining it and making it into a liquid. And then deposition, which is the opposite of sublimation, is taking a gas and converting it into a solid without first going through the liquid. All right. Finally, a phase diagram is a graph of pressure versus temperature that shows in which phase a substance exists. The triple point is the point on a phase diagram where all 3 phases, solid, liquid, and gas, coexist. And the critical point is the pressure and temperature above which a substance can't exist as a liquid. And so if you keep these things in mind and you understand how to do the Dalton's law of partial pressures problem and how to interpret a phase diagram, then you should be well set then for the test tomorrow. And so with that, I want to go ahead and wish you all good luck.